Hello everyone and welcome to our online presentation. My name is Gkioka and I am excited to present our research work co-authored with Professor Gregoris Mentzas. I am a researcher at the Information Management Unit, the Institute of Communication and Computer Systems of the National Technical University of Athens, and my current research focuses on the field of data analytics and machine learning. The submission number of our extended abstract paper is 8235, and our work is entitled Data Analytics for Technology Acceptance Monitoring of Smart Border Control Technologies. There has been an increasing demand for traveler clearance at border crossing points, and this fact has motivated research for finding more efficient solutions. Thus, there are some emerging new technologies such as the automated border control, which aim to enhance the convenience of travelers, the throughput of the border control points, and to enhance the national security. Despite this growing interest in novel smart border control technologies, there is currently a gap and a lack of information regarding their acceptance, both from the travelers and the border control staff perspective. Thus, Medicos comes into play, and Medicos project aims to create a holistic solution to address challenges for border management, both regarding societal acceptance and efficiency. Our research work aims to address the need for more efficient solutions and the need for gaining the travelers' social and political acceptance, as well as their satisfaction on the use of smart border control technologies. Thus, our research aims to provide a descriptive analytics framework for monitoring the technology acceptance of such systems, and the end goal is to enhance policy development and decision support. The data analytics in the Medicos project and our role in this project is, first of all, to harmonize data that stem from various heterogeneous sources by developing a data model in a hybrid way, to provide a portfolio of machine learning and statistical algorithms as well as data analytics techniques, with the end goal of discovering and uncovering patterns regarding the acceptance and efficiency of smart border control technologies, and exposing the obtained results of this analysis to end users through an interactive dashboard. Here you can see the architecture, the technical architecture, as well as the tools and technologies that we have used to produce our framework. And basically, let me begin by stressing the fact that this framework encompasses the life cycle of data from the moment that they are collected until their presentation to the stakeholders. Let's begin by the bottom part of this diagram, where the various data sources are shown. There we have distinguished some categories of data. For instance, we have the indicators of acceptance, which include social media data, smiley-based terminals, etc. We have the demographics and the user characteristics, such as the age, the travel habits, the cultural background, the country of origin of travelers and BCP staff. Then we have the third category includes the objective measurements of performance from BCP technologies, such as the total access time, the total time to capture the biometrics, such as, moreover, some situational factors, such as the flight's delay. And we have another category which focuses on the factors that may have an influence on the acceptance, such as what would be the perceived ease of use, how easy it is to use a BCP terminal, the impact on privacy, or the impact on health, the perceived impact on health. After collecting these data are harmonized using the data model, and then according to the nature of the data. For instance, if they're unstructured, such as text, or if they're structured, such as more tabular data coming from BCPs, they are sent and fed to the data analytics pipelines for the pre-processing and analysis accordingly. So we have the pipeline for unstructured data and the pipeline for structured data, where data are fused, cleaned, transformed, and then moved on for further pre-processing and analysis. And finally, we have the output of this analysis and the patterns that we have managed to uncover that are visually displayed to the stakeholders. And the stakeholders we have identified are mostly the policy makers, policy officials, and the border control officers. I will not go so much into detail regarding the technologies, but here you can have a view of the tools that we use to create and deploy our framework and our solution. We have divided the framework into 4 categories, the main building blocks of our framework, and I will go briefly through all of them to give an idea about what each and every one of them entails. So regarding the unstructured data pipeline, we have used and employed various natural language processing techniques to build this pipeline for unstructured data. And basically, this pipeline accepts as input text. And actually, it has multilingual capabilities and thus can handle text in various languages. One approach that we have used is using the text translation. The other is to use pre-trained deep learning autoencoders such as BERT and Roberta, for example, for French, and others depending on the languages. Here you can also see the various steps that are followed after translating the text or actually handling them in each regional languages. Then the text is being pre-processed. For instance, using tokenization, part of speech tagging, stop or removal, etc. And then we progress to the analysis. What's more important here, and I would like to stress, is the output of this component, the pipeline, which is basically the sentiment analysis, and that includes the classification of the sentiment, if it's positive or negative or neutral. And then we have the subjectivity classification, if the sentiment is actually not the same, if the opinion that is being expressed by the text is actually subjective or an objective fact. Then we have the context of discussion where basically keywords are being identified, and we, for instance, for tweets, we can extract some descriptive analytics regarding the frequency of hashtags or mentions, and thus identify what would this particular piece of text is about. Then we have the topics extraction. Basically, we extract using topic modeling techniques such as LDA, LSIA, HTTP, and other algorithms. Moving on, we extract named entities such as organization, people, so we are able to identify if a specific name is frequently mentioned in the text. So using NRE techniques, that's how we proceed with the extraction of the name entities. And finally, we extract key phrases using also state-of-the-art NLP models. Finally, we are also able, for instance, for tweets that we did some experiments on, we are able to extract some descriptive analytics such as the trends over time, geolocation analytics, etc. So based on the amount of information that we have on the data. But this pipeline is very generic and can handle multilingual textual data. Moving on, we were going to focus on the structured data pipeline. So for the structured data pipeline, here you can see a pretty straightforward machine learning pipeline for structured data. So we have used this dedicated pipeline for pre-processing, for transforming and analyzing data from various sources, such as the data that stem from BCPs, of course, anonymized, questionnaire data, flight data, and road information data that may be available to the project. So the data are first prepared by doing some initial filtering, pre-processing and cleaning, outliers removal, feature scaling, feature selection, and after the application of any selected algorithm that I will go into detail afterwards, the machine learning model is actually evaluated and fine-tuned using, for instance, grid search, hyperparameter tuning before actually being deployed and presented finally to the stakeholders. The data that and the output finally of our analysis include aggregated data, cross-tabular statistics, correlations analysis, trends, and actually more that I will go into detail afterwards when we talk about the models that we're providing as machine learning training. And finally, the data from various locations and formats, in addition to the output from the described pipelines, are combined and analyzed. So here you can see the categories of the algorithms that we're able to provide through our suite of developed inside the pipeline. So here we have, initially, as I mentioned before, some descriptive capabilities, including data filtering, data aggregations, cross-tabular statistics, trends, etc. But then we also offer the possibility to our users to deploy a classifier, which are basically machine learning models for classification. For instance, one of the use cases we use it here is to classify an information and see, for instance, if it's 0 or 1, or we have this binary possibility, or we have a multi-class classification. For instance, when we have some questionnaire data, we're able to analyze and see if finally this user has accepted or not the technology, or else in which categories some high acceptance, medium acceptance, or low acceptance. So we have a multi-class classification. Then we, moving on to the next category, we do provide some categories of deep learning models and algorithms. For instance, neural networks are being offered to the users. And finally, the regressors. For instance, some machine learning models that we use include the prediction of an acceptance score based on the questionnaire, on questionnaire data. So we're able to deduce the final score of acceptance, or a prediction regarding the efficiency of a BCP based on the number of expected arrivals and departures in a specific setting location. Here you can see some of the algorithms. I will not go into too much detail, but just to see that we have a multitude of both classification and regression related models, and the classification includes both multi-class and binary classification. For regression, for instance, we have used random forest, linear regression, neural network support vector machines, AdaBoost, and light GBM. So basically, based on the task at hand, we offer the possibility to the user and guidance to use a multitude of these to test, to try to evaluate various approaches. And actually, the evaluation is done using these metrics that we have set, both for classification and regression, and based on the expected outcome of this of the established metrics, then we are able to select and fine-tune the model based on the specific source of data that it has been trained on. The structured data pipeline, just to conclude, some types of outputs that we have been able to produce and that our model and our framework can actually handle include correlations between the demographics and the profile, as I mentioned before: age, gender, education, travel habits, the cultural background, and the other class of data, which are the operational data, such as the waiting time to cross the border, the length of a queue where people are waiting in BCPs, system errors, etc. And finally, the metrics that regard the acceptance and efficiency of the BCP. Another type of output is the clustering of profiles, both for the travelers and the border guards classes, the cross-tabular statistics, predictions that are based on our models, and the importance and the weight of various influencing factors to be able to be presented in a way so that people understand why this prediction was actually chosen by the model. So some explainability is also incorporated as part of our models. Moving on to the bias, as you can understand in various machine learning and generally AI approaches, we need to deal with the concept of bias. So here the biases that are referring to various stages, for instance, for the data collection, to the pre-processing and the analysis and model selection, we have considered these biases and we have put continuous effort in mitigating them by including the notions of fairness and balanced representation of the data assets. So for the data collection, we aim to check for balance in protected attributes, and protected attributes, I mean the age, the gender, any sensitive personal information that may be used to discriminate people. Regarding the data pre-processing, one of the ways that is used in literature is the handling of noise and data cleaning, and the selection of the appropriate approach, such as the deletion, the data imputation, based on the source of data that we're dealing with. And the data analytics and model selection, there are also biases that can be introduced in the pipeline as part of this let's say, step. So we have implemented various algorithms which can also be evaluated and cross-checked amongst each other, and calibrating the models and fine-tuning them is of absolute importance. And these are some techniques that have been used in literature, but we wanted to take this bias mitigation and not just identify bias, but actually mitigate it and take it to another level. That is why we have been investigating various tools that exist and are used in literature, and we have selected the AI Fairness 360, which is a Python package, and it includes a set of metrics which is quite comprehensive for datasets and models to test for biases, identify biases, and provide explanations for metrics, and be able to provide algorithms to mitigate finally the bias in datasets and models. So in here you can see some of the bias metrics that we have used to identify and see if there is any sort of bias that is inherent in our data sources. And in various steps of the pipeline, for instance, in the pre-processing or the in-processing and the post-processing, we aim to include various algorithms to handle this kind of inconsistencies and biases that are introduced in our data. Finally, we will be talking a bit about the visualization part. So we are able, as I showed before, to produce various analytics for structured and unstructured data and to handle biases in the pipeline. But all of this would not be of such use unless it was actually shown and displayed to the end users and the stakeholders of our platform. And thus we use an interactive dashboard which is currently being developed, and here you can see some snapshots that includes some information, some test data that are not actually they do not correspond to real data that we have, and this is for security, let's say, purposes. So We have used a lightweight open source application, and the aim is to enable stakeholders to interactively monitor the acceptance, to observe the trends, to observe the changes in the acceptance and its influencing factors, to see, for instance, differences in acceptance based on the geographical location, zoom in, explore the output of the pipelines, to filter data, view raw data, and maybe perform some basic analysis based on the shown metrics. All in all, our proposed framework encompasses the life cycle of data from the moment they're collected until they're presented to the stakeholders. So, from the data collection, pre-processing, analysis, and visualization part are being covered by our framework. When the data collection is finalized and the functionalities of the systems are fully implemented, this solution that we built is going to be evaluated further and validated, hopefully, by domain experts. And we expect that the insights and the findings will enable evidence-based policy and decision support regarding the acceptance monitoring of smart border control technologies. I would like to thank you very much, and please, if you have any questions, do not hesitate to send me an email, and I will try to promptly respond. Thank you very much.